When we think of solar energy, we think of fancy solar panels like these, but really, we can harness solar energy really easily. Introducing the solar oven, brought to you by Under Armour. Building a solar oven isn't all that hard. All it takes is a cardboard box, some saran wrap, something black, and aluminum foil. Now it's time to list the steps in making it. First, cut a large flap into the lid of the box. Then, line the inside of the box and the flap with metal foil. Next, place some black paper on the bottom of the box. Cover the hole completely in the lid with the plastic wrap. And prop up the metal covered flap at a slightly acute angle. This visual might help. Now that we know the supplies and steps involved in making a solar oven, we need to know how it works. We all know that solar energy comes from the sun, but the question is, how does the sun's radiant energy get collected in the oven? The electromagnetic waves, otherwise known as light waves, travel from the sun to the reflective flap, where it bounces through the transparent plastic wrap into the oven. Once the heat has come into the oven, hot air starts circulating. Warm air rises to the top and cold air sinks to the bottom, creating a current. Soon, most of the air is warm. This transfer of thermal energy is called convection. With the solar oven, the heat energy is trapped inside. How does this work? Well, let's look at the materials used. Plastic and cardboard are insulators. What are insulators and conductors? Conductors are materials that thermal energy runs through very easily. Their atoms have plenty of free-flowing electrons to carry energy. Insulators, however, don't let heat through as easily. Their atoms have less electrons that flow through the material. Conductors generally have a low specific heat, which means it takes less energy to heat them up. Insulators generally have a high specific heat, which means they need more energy to heat up. Some changes I might make to the design of my solar oven to make it more efficient are: I would add a fan so heat would circulate more. I would use a magnifying glass to direct radiant energy. More radiant energy will be more thermal energy, turn into more thermal energy. I would add more insulation as well, so that less heat would escape. A solar oven can be used to cook food, but what else can it do? Maybe we could use a solar oven to heat a home. Or we could use a design to house tropical plants. Maybe it could even be used as an incubator of a sort for animals. The possibilities are endless. Some limitations to the solar oven include that the sun is not always out, but you can use an artificial light source when needed, or just don't go when there's not any sun. The second thing is they don't get very hot. You can use lots of insulation and place the oven high in the building.